We're going to graph the transformations with knowledge and not a bunch of work, okay? We're going to graph the transformation with knowledge and not a lot of work. So remember, I just asked you this question a few minutes ago. Your horizontal asymptote will only move if the graph moves up or down. So in example 1, x plus 2. The plus 2 is directly being added to the x, so that is a transformation to the left 2. Okay? You can think it or write it. It doesn't matter, but you got to know that means to the left 2. You're going to sketch out your little graph. You can use graph paper if you want to, but you can probably do these without graph paper. And remember, we picked 2 points that we're going to move around to sketch the graph out. That first point was 0, 1, so it's going to go to the left 2. And then the other point was 1, 2, and it's going to go to the left 2. If we move left or right, our horizontal asymptote does not change. If we move left or right, our horizontal asymptote does not change. It's still the x-axis. Now the directions say use transformations to graph each function. Give equations for the asymptotes and state the domain and the range. So the asymptote is still at the x-axis, which is y is equal to 0. The domain is negative infinity to positive infinity, and the range is parentheses 0 to infinity. Okay? Your domain is always going to be negative infinity to positive infinity, because that's just true for all exponentials. They're going to go forever to the left, and they're going to go forever to the right. The range will change. Okay? The range will change based on what your transformation is. Example 2, what's the transformation? Up 2. Okay? So we're going to take our graph. We're going to sketch it out. We're going to use those 2 points. Now the first thing that I do is if I'm ever moving up or down, I automatically draw in the new asymptote. Moving up or down will cause the asymptote to move. So I'm going to go ahead and sketch in using my little yellow highlighter. My asymptote is not going to be the x-axis anymore. It's going to be the line. What would be the equation for that line? Y equals 2, because they're going to want you to name that. It's y equals because it's horizontal. Okay? And then you can take the 2 points that we want to use from our t-chart, 2 to the x, and you can move each one of those up 2 and sketch in your graph. And these are going to be growths. Okay? If the parent function is a growth, all the other graphs will be growths. So if we're at 0, 1, and we go up 2, we're at 0, 1, and we go up 2. We're at 1, 2, and we go up 2. 0, 1, go up 2 from there. 1, 2, go up 2 from there. And then you can sketch in your graph. You're going to be approaching a new asymptote. If you do not draw that in, you might make the graph approach the x-axis, excuse me. So that's why I always like to draw in that new asymptote so I don't forget where the graph's approaching this time. The domain is negative infinity to positive infinity. The range changes on this one. It's 2 to infinity. Does everybody get that? The graph is going to approach y is equal to 2. It's not going to approach y is equal to 0 anymore. It's going to approach y is equal to 2. Example 3, there are 2 transformations. X plus 2 tells me what? To the left 2, and minus 1 on the outside tells me down 1. Okay? So is my horizontal asymptote going to change? Yes. Anytime you move up or down, horizontal asymptotes are going to change. So I'm going to go ahead and sketch in my new asymptote, which is going to be down 1. And that equation is going to be y is equal to negative 1. You're going to take the 2 points and you're going to move each one of those points to the left 2 and down 1. So I'm going to start with 0, 1. I'm going to go left 2, down 1. that puts me at negative 2, comma 0. And then if I'm at 1, 2, and I move left 2 and down 1, does that put me at negative 1, 1? I think so. Y'all are quiet, so I don't know whether y'all getting this or not. Does that one make sense? All right, domain. Range. Negative 1 to infinity. Example 4, there's a negative. Anytime there's a negative, that means there is a reflection. You just have to decide whether it's a reflection over the x-axis or whether it's a reflection over the y-axis. If it's out in front of your equation, it's a reflection over the x. So this negative is not out in front, so this is a reflection over the y-axis. So this one will be pretty easy to do. Is the horizontal asymptote going to change? No, because you're not moving up or down, and so we're just going to reflect over the y. So if I have the point 0, 1 and I reflect it over the y-axis, where does it go? It stays right there because it's on the y-axis. If I have the point 1, 2 and it reflects over the y-axis, then it changes to negative 1, 2, and then the growth graph turns into a decay. The horizontal asymptote is still at the x-axis, which is y is equal to 0. Domain is negative infinity to positive infinity. Range is 0 to infinity. If you want to use graph paper, you can use graph paper. There's graph paper in here if you want to. If you want to just sketch them out, it's up to you. All right, example 5. This is probably one of the worst transformations there are. And it's any time that we stretch or shrink. And so that's what's happening in example 5. So if there's a number on the outside, okay, that's a vertical movement. That's some type of vertical movement. If the number is on the inside or directly affecting the x, it's a horizontal movement. So I know that that 1/2 is outside, so I know it is a vertical, and it's exactly what we think. It's a vertical shrink. So that means we're dividing the y's by 2. If that were 1/3, we would be dividing the y's by 3. It's a vertical shrink. If we're shrinking or stretching, that will not affect our asymptote. Only moving up or down will. I think I'm going to make this. I'm going to make my dashes a little bit bigger so y'all can see what we're doing here. Alright, so what's that first point that we're using? 0, 1. But we're going to cut the y value in half, so that's going to be at 0, 1, half. And then the next point that we're using is 1, 2, but we're going to cut the y value in half, so we'll be at 1, 1. Okay? Now remember, we know it's a growth. This time it's just going to be shrunk vertically, so it's not going to grow as quick. It's not going to go up as quick. It's still a curve. It's still a curve. Yeah, it's just a slight. The growth is not the same because we're shrinking all the y's. Domain is negative infinity to positive infinity. Range is 0 to infinity. Equation for the asymptote is y equals 0. Alright, we're going to do the same thing with the next set of examples, except we're going to change our parent function. We're going to change our parent function. Everybody got example 5? Alright, so I already have a t-chart for you, but you would have to make a t-chart and get at least 2 points. So where is the E button found on your calculator? Second LN, okay? You would have to make the t-chart. I'm not going to waste your note time for this because this is what you did last night in your homework, okay? So you would have to make the t-chart. I've already made it for you. And then I would pick at least 2 points. And again, I always like to pick these 2 points. Pick at least 2 points. I've made more than enough points for you. pick at least 2 points and do your transformations. Why is e to the x growth? Because e is a value that's greater than 1. It's a real value. It's not an unknown. It's not a variable. It's a value, 2.71, yada, 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 yada. Okay? So we're going to take those 2 points, and we're going to do the transformations on a new graph. So we have a new parent function here. So in example 6, what's the transformation? Left 1. We'll do a couple of these, and then we'll just talk about the transformations. Left 1. Now this one's going to be a little bit harder because the second point is a decimal, but you'll do exactly what we did for 2 to the x. You'll just have to move 1, comma 2.7. If you don't want to use 2.71, I don't think there's going to be a lot of difference between you graphing 2.7 and you graphing 2.71. Alright, so we're moving everything to the left 1. That will not move our horizontal asymptote. So 0, 1 was on our original graph. We're going to go to the left 1 there. And 1, 2.7, we're just going to kind of estimate, and that will go to the left 1. So we're moving the point 0, 1 and the point 1, 2.7. And then we're going to sketch it in. The equation for the horizontal asymptote is y equals 0, domain, range, 0 to infinity. There's 2 transformations in example 7. The x plus 1 is telling you to move to the left 1. The minus 1 on the outside is telling you to go down 1. Anytime you move up or down, you are moving the horizontal asymptote. So again, I would go ahead and sketch in my horizontal asymptote. Down 1. Again, if you forget to do that, you might draw your graph approaching the x-axis, and it's not approaching the x-axis because the whole graph is being moved down 1. So the equation for that asymptote is y is equal to negative 1. Then you'll take at least 2 points from your original graph, and you'll move each one of those left 1 and down 1. So if I take 0, 1 and move left 1 and down 1, I'm at negative 1, 0. If I take 1, 2.7 and I move left 1 and down 1, I'm at 0, 1.7. I think. Is that right? And I'm going to sketch that in. The domain is negative infinity and positive infinity. The range is negative 1 to infinity. Example 8, what is the transformation? Reflection over the x. Reflection over the x. So instead of having 0, 1, I have 0, negative 1. And instead of having 1, 2.7, I have 1, negative 2.7. And then I have to go back and think about that original graph. So if that original graph, I'm just going to kind of sketch it in, which was this, gets reflected over the x. You can use those 2 points, but sometimes I have a little flashback about what it really looked like to begin with, and I'll erase it now. I didn't move up or down, so the horizontal asymptote is still at y equals 0. Domain, negative infinity to positive infinity, and the range, think about this. Good, negative infinity all the way to 0 with a parentheses. Example 9 is a vertical shrink. So that means that we're dividing our y's by 2. If that would have been a 2, then we would be multiplying our y's by 2. Again, we're not going to move the graph up or down. I'm going to make my little marks a little bit wider so we can kind of see what's going on. So 0, 1 turns into 0, 1, half, and then what's half of 2.7? About 1.35, which is about 1.4. So instead of doing 1, 2.7, we'll do 1 and about 1.4. Kind of estimate there.
Will there ever be a case where the domain isn't negative positive?
You can't do anything to an exponential. You can move it up, down, left, right, flip it over the x, flip it over the y, stretch it, shrink it, and it's always going to go forever to the left, forever to the right. Just the range will change. Okay, any other questions? All right, the next set of directions are going to say graph functions f and g in the same coordinate system. That just means on the same graph, okay, on the same x and y axis, you'll have two graphs. Give equations of all the asymptotes. So this really isn't changing things. I still have 3 to the x and 3 to the negative x, and those are transformations of each other. I'm going to erase this so I can move the graph up a little bit for us. Still doing the same thing here, except they're just asking you to put everything on one graph. Okay? So you have to realize that little f to the x, that's the parent graph. And then what is 3 to the negative x? What is it telling us to do? That's a reflection over the y-axis. So in your head, can you come up with 2 points that we can use? Okay, 0, 1, and 1, 3. Does everybody know where I'm getting at without making a big T-chart? You need to have at least 2 points. All right, so your original graph has the points 0, 1, and 1, 3. Anytime you have more than one graph, you're going to need to label those. So you'll label that one f of x. They're asking for you to give the equations of all the asymptotes. The asymptote for that graph would be y is equal to 0. And then we're going to take that graph and reflect it over the y-axis. So 0, 1 is not going to move because it's on the y-axis. But 1, 3 will move to negative 1, 3. And then you will sketch in g to the x. And g to the x has the same asymptote as f to the x, so you'll just leave that y equals 0 out by your asymptote. Example 11 goes for the same set of directions, or just changing the parent function or the original function to 1/2 to the x. Is that a growth or a decay? It's a decay. 1/2 is between 0 and 1. So we've got to get a couple points that are on that graph. So 0, 1 is on the graph, right? But what happens if x is 1? What is y when x is 1? 1/2. Okay, so you do need to kind of keep in mind this one's going to start high and finish low because the base is between 0 and 1. So that's the original graph. If you want to use more than 2 points, you can. So we've got 0, 1, and then we've got 1, 1/2. The asymptote for that graph has what equation? Y equals 0. Remember, you're graphing two graphs on the same graph, so we'll label this one f of x. That is your parent function, and what's the transformation on the g of x? Okay, to the right one and up 2. Did anybody think that we were going to do a shrink? Okay, the 1/2 makes me think we're going to do a shrink, but what's the difference about this 1/2 than the 1/2s that we've seen before? It's in parentheses, and it's the base of the exponential equation. There's not a 1/2 being multiplied times your base. That is the base. Okay? So we're just going to take our 1/2 to the x graph, and we're going to move it to the right 1 and up 2. That is going to change our horizontal asymptote, so I'm going to go ahead and sketch it in, up 2. And then we're going to take each point, and we're going to move to the right 1 and up 2. So 0, 1 to the right 1 and up 2 puts me there. And 1, 1/2 to the right 1 and up 2 puts me here. Still a decay, because I've just moved it right and up. It's still a decay. And what's the equation of that asymptote? Y equals 2. Then on the last part of your homework, you're going to totally change gears, and you're going to be a banker, and you're going to use some interest formulas, and you're going to calculate interest. All right, you do not have to memorize the two equations that you're seeing in the next set of directions. You do not have to memorize those, so make yourself a note. You don't have to memorize them, but you do have to know how to use them. So the directions say, find the accumulated value of an investment of $5,000 for 10 years at an interest rate of 6.5%. If the money is A, compounded semi-annually, B, compounded quarterly, C, compounded monthly, and D, compounded continuously. So I'm going to go ahead and tell you that on the PERT formula, you're going to use A equals P e to the RT. Oh, I've already got it in your notes. When they are telling you that the interest is collected continuously, that's when you use the PERT formula. Okay? Continuously. The A equals P, the one that has the N in it, the N is when they tell you amount of time, like semi-annually, quarterly, or monthly. So you'll use the formula with the N in it when they do not use the word continuously. So when we do the A part, because they say semi-annually, that means that your N value is 2. Why would N be 2 if it was semi-annually? Twice a year. So they're going to collect interest twice a year. So that's what your N value stands for. I think most of you are going to know R stands for what? Rate. T stands for time. You may not know what P stands for, but I bet you could figure it out. Dr. Scrimpture is our principal, but in mathematics, when you go to the bank and you invest money or you borrow money, that is called your principal amount. Okay? If we're actually investing money here, it's an investment. So our principal, guess what amount would be our principal in this problem? $5,000. R is your rate. We have to take the percent sign off and move the decimal 2 places. T is time. So if we use that formula with N being 2, it's A is equal to our principal, which is the amount that we're putting in. Because our principal is what we're investing, and Dr. Scrimpture is investing in you. That's one way that you can think about it. Then the formula says 1 plus, You can't use 6.5 because it has a percent sign on it. So you have to remove the percent sign, and that changes it to 0.065 divided by n, which is the number of times a year that they're collecting the interest. This one says semi-annually, so that is 2. And then the formula says n again, so that would be 2 times the number of years you can leave your money in the bank, and that's going to be 10. Now, however you want to do this, you just want to be really, really careful. I would go ahead and multiply 2 times 10, okay? And I would go ahead and say that's going to be 20, and then I would just enter the rest of it straight into my calculator. 5,000, left parentheses, 1 plus 0.065 divided by 2, right parentheses, power key 20, and you should get 9,000. You tell me the rest of it. 479, and this is money, so we're going to round to the penny, so that's going to be 19 cents. The B part says we're going to take the same amount of money, the same principal, the same interest rate, the same time, but we're going to compound the interest quarterly. Okay, quarterly means how many times a year? 4 times a year. So in the B part, our N is going to be 4. Should this make us more money or less money than when we collect it semi-annually? What do you think? What do y'all think? You're going to collect the interest 4 times instead of 2 times. It's going to be, you're going to make more money because you're going to make interest on your interest. Y'all get that? You don't get that? So you put the money in. After a quarter, they're going to collect the interest, and then it goes back on your principal. Then after another quarter, they're going to collect the interest again. Then they're going to add that back to your principal. And then after another quarter, they're going to collect the interest again. So the more times you collect the interest, the more money you make because you're making interest on your interest. Trying to relate that to something that y'all might. She said she hopes her husband understands this. Is that how it works in your family? All right, so the only thing that's going to change is that 2 is going to change to a 4. And y'all probably already got it worked out, and me and Mary Frances are having a conversation over here. So then it's going to be 4 times 10. And then I would go ahead and do that in my head and do a 40 there. And then put that in your calculator. And you should get something a little bit more than when you collected the money, collected the interest semi-annually. Not going to be a lot more, but it'll be a little bit more. Shout it out when you have it. And it's money, 79. Have to round to the penny. All right, we're almost finished. Y'all are doing so good. Hang in there. All right, the C part, it says we're compounding monthly. So how many months are there in a year? 12. So we do the same formula, except N is going to be 12. So it's going to be 5,000. You don't even have to write this part down if you just want to use what you've done before and punch it in your calculator. Whatever works for you. 12 times 10, so that exponent would be 120. And then this, again, should give you a little bit more than $9,527.79, and it gives you 9,560, I hear it over there, and how many cents? 92 cents. So one way to kind of double check yourself here is if you're collecting interest more times, you're going to have more money at the end. All right, and the last one is collecting it continuously, every second, every minute. So we have to change formulas here because continuously doesn't give us an end value. So that's why we have to use the PERT formula for this. Anybody remember Pert shampoo? Are y'all too young for that? Yeah. It was in a green bottle. Smelled really good. Alright, remember your rate. You have to still move the decimal. So it's going to be 0.065 times 10. So before I put it in my calculator, I would probably go ahead and multiply 0.065 times 10 and then enter that into my calculator. So that's going to be 5,000 e to the 0.65. And remember, to get to e, you have to do second ln. And this should give you an amount that's a little bit more than $9,560.92. $9,577 and how many pennies? 70 cents or 70 pennies. So the end of this section, you'll have some interest problems. They'll give you the two formulas. You don't have to memorize them. You just have to know how to use them.